Back again with another video on solid modeling tools. This time it'll be a little bit different because I'm going to be showing you how Microvellum Solid Model Analyzer can be used for more than just the extruded products we get from the 2D section drawings. It works with any 3D solid. Let me show you. In a previous video of this training plan, I analyzed the 3D solids created by the extruded product builder to give me this Microvellum product. In short, that's what the Solid Model Analyzer does. It takes any 3D solid and turns it into a Microvellum product. These products are similar to others in the library, where the data inside of them control how they're drawn and built. But the one major difference is that they're not parametric, meaning that there's no formulas or anything that make them dynamic. So changing the width or the height in the prompts really doesn't do anything. It'll just mess up the 2D plan drawing and give you the wrong information on reports or labels. The data in the product is really just used for manufacturing. Before getting into creating more 3D solids to analyze, I want to do a quick review on how Toolbox knows how to pick the right drill or router bit, and how to make sure certain tools are used and others are not. This can all be done in the tool file. There's a setting for each router bit called pocketing/SMA routers. If this box is checked, Toolbox will attempt to use this tool when analyzing as long as the diameter will work with what's called out in the product. For example, a 3/4 bit's not going to route a 1/4-inch dado. And this V cutter isn't going to be used at all because the SMA setting isn't turned on. The other settings for how Toolbox will analyze the product under Toolbox, Setup, and Options. Then select the Solid Analyzation tab, and here's where you can set up some of those parameters. We have the material thickness and other settings like the area of a pocketing cutout or the amount to increase curved or non-planar parts. Okay, now back into the drawing. Let's start making some 3D solids to analyze. I'll use the AutoCAD box command for a simple cabinet box. 2 sides, a top and bottom, and a 1/4 inch applied back. First with the 2 sides, just give myself one and then I'll just copy it, move it over. And then for a top and bottom, again using the same box command and copying it to make that second part. And finally, sticking on that 1/4 inch applied back. Pick the points in each corner and give it a thickness of a 1/4 inch. Now, because these are 3D solids, Toolbox will be able to analyze this and turn it into a product. So it would be pretty easy to add some construction holes for attachment, and I'll show you how to do that towards the end of this video before creating a work order. But next up, I want to show you how you can really turn any shape into a 3D solid and then into a Microvellum product. Now, this could be really useful for those one-off parts or custom-shaped countertops. I'll start with the polyline, make sure it's going to be small enough to fit on a sheet of material. And then I'll add a grommet hole. And now this 2D object can be extruded into a 3D solid. To do this, you'll want to use the press pull command. Select inside of the area that you want to pull, move your cursor in the direction it'll move, and then give it a value of 3/4 or whatever thickness the material will be. Next up, analyze the solids. I'm going to go ahead and pick all the solids to analyze. This will create just one product in Microvellum, so analyze separately if you don't want them to be combined into one. I'm going to do just the cabinet first and then go back for the countertop. After selecting the parts to analyze, Toolbox recognizes them as 3D solids and asks to have a material assigned. Make sure that the thickness of the solid matches the material thickness. I'm just using 3/4 plywood for all of this. And now it's ready to be placed in the drawing. Go into part properties and you can add those construction holes as I mentioned. Select the part, then the machine tokens tab, and right click to add a token from the clipboard. You can choose from screws, cams, or dowels. You can see the other options that we have here. I'm just going to go ahead and use cams and pick the one with the 4 at the end. The 1, 2, 3, and 4 represent each edge of the part. Now do the same for the bottom and pick that same token. And there it is. We got some cams drawn in this cabinet. Now, if you want to go back and change the face where the hole for the cam is drilled, you'll want to update the cam face to 5. And then just that simply, you can add machine tokens to the product after analyzation. Now I'm going to go ahead and repeat the steps for the countertop. pick the material, and save it to the drawing. And now both of these are ready to be included in a work order. I'll open up part properties again so you can see how Toolbox recognized that hole and created a machine token for it. The tool it's using is coming from the tool file where it had the SMA router option. And there it is also showing the part in 2D to confirm that we have that machining. Okay, now to create a work order. Select the products in the drawing and process the parts. Just like any other work order for Microvellum products, you can check out the nest drawings and make any necessary edits. And now for the last part of the video, where I'll import a file into this drawing and use that as the 3D solid to analyze. This can be done using third-party apps like SolidWorks or Inventor. You're going to want to go to the Microvellum logo in the corner and select Import. These are the different file types that can be imported into the drawing. So I have this one ready to import. Select it and then wait for Toolbox to let you know it's ready to be added. Okay, now depending on how the drawing was first created, you might need to scale it to the correct units. Obviously, this one isn't the correct size. First, let me rotate it using the 3D rotate command. And then now type scale in the command line, or the shortcut SC. Select the object, and I'm going to tell it to use a reference length. So I'll pick 2 points that'll be the width, and then enter the value I know that it should be. For this cornhole board, I know it needs to be 2 feet wide. And after you hit enter, let's type DI so I can pull a distance to verify. And 2 feet wide and just under 4 feet long. That's close enough. I mean, if I was really wanting to get these parts cut, I would go through and make sure each of the 3 solids are matching the correct thickness and all the sizes were correct too. But I wouldn't even really be able to do that at this point with the block in its current state. So that's because it's just a block reference. So I'll need to explode it so those parts are actually 3D solids. Also, these holes, I would want to make sure match the diameter of a drill bit that's in the tool file. Otherwise, they're going to get ignored. Now, just like before, use the solid model analyzer and go through picking the correct material. This message here is letting me know that the diameter of those tools don't match the SMA tool in the tool file. So just hit OK and move on. Now I can place the product, and in part properties, you can see that the parts with the machining error have comments telling you what that error is. All right, and that's it. That's how simple it is to use Toolbox to analyze 3D solids and turn them into a Microvellum product. That'll wrap it up for this one. I'll see you next time for more learning about Microvellum Toolbox.